Hi, everyone. Welcome to the final class of the day before our big event, which is going to be Women Thrive in STEM. But yeah, so before we get to that, we are going to have one final class, which is going to be on coding. So as I mentioned previously, this class is going to be also be teaching you guys on how to do USACO bronze. And USACO or USACO is sort of like a coding competition that people all across the world participate in. There's 4 different divisions. There's the bronze division, the silver division, the gold division, and the platinum division. So there's sort of different sorts of levels that you can sort of work towards in this specific competition. And after you finish a division or get a certain score on the contest, then you advance to the next division. So it's sort of like a level up system, which is pretty cool. And this class is primarily going to be focusing on the first division because even though it is the first division, coding is still pretty challenging. So there's still lots of different things that you might need to learn. And yeah, so normally your teacher will be Daniel Ju, but because Daniel currently is not able to be here for today and tomorrow, I will temporarily be stepping in and helping him teach the first 2 classes. And then after that, you guys will have your normal teacher back. So hopefully things go well. And yeah, does anybody have any questions before we begin? All right, if not, then let's get started. Oh, is it suitable for people who do not know coding? Yeah, so the way that we've tried to structure this class is sort of so that even people who are not that familiar with coding still might be able to get something out of it. Although I will say that if you haven't done any coding class before, then this class will definitely be a little bit more challenging. I think a good way to tell if you might be able to get something out of it is to see if you can understand what's going on today. And then if not, then it might be a little too challenging for you. Okay. Yeah. So without further ado, let's get started. So first of all, there's lots of different sorts of programming languages that you can create code in. And the one that we're specifically going to be using today is this language called C++, which is one of the most popular languages in competitive programming. And today, instead of going over like really major problems that we might be solving in coding competitions, we're going to quickly go over an introduction of C++ first to sort of understand the basics of how coding works, as well as the fundamentals of how C++ works. So let's see exactly what we're going to be learning today. So there's a few different types of terminology that we generally will be applying in our coding. So there's 6 different things that we're going to be going over today. These are variables, types and data structures, libraries, I/O, which stands for input and output, conditionals, and loops. Know that this is going to be a very quick overview over all of the different sorts of concepts, as most of the time for example, in school computer science classes, you will be spending a lot more time going way more in depth into each of these specific topics, because there's a lot of sort of nuance that goes on with each of these specific topics that can be really important to understand. So you can think of this sort of as more of a review of these topics if you've learned them before. And yeah. Now, before we get started, I know that some of you might not have access or might not have used C++ before. So the best way to sort of still be able to follow along with what's going on is to search up online C++ compiler, as I've done here, and then go to this online C++ compiler, which says like GDB online debugger. So if you click on this link, then it should take you to an online C++ compiler, and you should be able to follow along. Note that most of the time when you're coding in C++, you'll be using a software that you download to your computer, which is called an IDE. But in my opinion, using this C++ compiler, this online C++ compiler works just as well, at least for our purposes. So yeah. So I'll give people a couple more seconds to get to this if they still have not gotten here. And now let's quickly go over what exactly everything in here is doing. So this stuff up here is sort of just a comment. So this stuff up here doesn't actually change the code. And you might notice that there's a lot of stuff that's written in our code already. And for now, we don't have to worry about exactly what all this is doing, but just know that it really makes sure that our code can run successfully. So you see, like, we have this hashtag include IO stream. This just makes sure that our program actually runs. This using namespace std also just makes sure that our program actually runs. And then the interesting thing of what exactly is actually happening is going to be inside of this int main method. So int main with these two brackets pretty much just says whatever is inside of these two brackets is where we are going to be typing. So this int main sort of just tells the computer, okay, you need to be looking at everything that's taking place in between these two brackets, and that's what your computer is going to be running for the time being. This returns, and one more thing, which is that this return 0 at the end sort of tells the int main when to stop. So we have this int main, the computer knows that it needs to sort of look at what's going on inside of the two brackets, which is what I've highlighted on the screen. It's going to run this command, and then it's going to run this return 0 thing. And whenever it hits return 0, that just tells it to stop. So what does this cout hello world do? Well, this is sort of just a command that we can broadcast to the computer, telling it to do something. So in this case, cout means to output something to the computer. These two less than signs just indicate that we're going to be pointing to something. So cout, these two signs, and then this text tells us that we're going to be printing out whatever this text is. So if we click the run button, we see that this program is going to run what's in this int main method, and it's going to run specifically this command first. So first we run cout, and then if we put two less than signs, and then the message that we want to print inside of these two quotes, like something that's inside quotes means that it's sort of a message, then we see that our program has outputted exactly what we want it to say, which is hello world. And we can change this in multiple different ways. So for example, if we wanted to say like, I am the best with exclamation mark, then we could run this too. And because this command here just tells the computer to output some sort of text, our computer program will still output whatever we've written in here, which in this case is I am the best. So we can edit this message inside of these quotes to be whatever we want it to be, and it'll allow us to print out stuff that's happening. And you guys can try this for yourself inside of your own C++ compiler if you want. I'll give you guys like 15 seconds or 20 seconds or so to replace the message and see if it can do something. And one more thing that you might have noticed is that a lot of these commands have a semicolon at the end. And this semicolon at the end of all of these commands tells the computer, okay, after you see the semicolon, it means that this line is over, or this command is done. So after we've printed out, I am the best, we want the computer to stop and go on to the next line. So we put a semicolon at the end. And there's not really a reason behind this. The semicolon was just sort of chosen to indicate that this is the end of the line. So it's sort of become a standard to use a semicolon at the end of every single computer program line that you run. So for example, there's a semicolon here, there's a semicolon here, and there's a semicolon here. Yeah. Does anybody have any questions so far? All right, if not, then we will continue. So let's now move on to the first part of what we're going to be talking about today. So let's talk about variables. So what is a variable? Well, a variable is something that changes over the course of a program. What this means is that a variable is sort of similar to what you might have learned in algebra. It's like something that takes the value of something else. So there's lots of different things that we know can change. So for example, the average rating of a movie might change over time. A person's age changes as the years progress. For example, I might have been 17 years old last year, but now I'm 18 years old. person's name can also be changed. If they decide that they no longer like their name, then they can go through the legal process to change that. So because there's lots of things that can change, then in a computer program, we create variables to represent these things that can change. Yeah. And something else that you might notice is that all of these specific things that can change have a specific type of value that they're going to take on. For example, the average rating of a movie is always going to be a number. For example, we could say that the average rating of a movie is 2, 3, 5, 8, and so on. But we can't say that the average rating of a movie is a string, or we can't say that the average rating of a movie is a word, like water, because that wouldn't make sense. Similarly, a person's age must always be a number that's bigger than 0. For example, it could be 1, 5, 17, but it can't be something like -3. It can't be a single character like A. That doesn't make sense. You can't be A years old. And it also can't be a word like recorder. That doesn't make sense for a person's age either. And similarly, a person's name must be a word. It has to be like Rich or Daniel or something along these lines. So you can see that there's lots of different things that can change, which we call a variable. And each of these variables has a specific sort of type of descriptor or type of value that it has to take on. For average rating, it has to be some sort of real number. For age, it has to be a number that's greater than 0. And for name, it has to be a type of word. So now this begs the question, how do we pass this information onto the program? And the way that we are able to do that is with the following code. So the first thing to notice is that, okay, so what we've written here is an example of C++ code. And whenever you have 2 slashes before any part of your code, that's not actually part of the code. That just means that you've typed a comment. So here, this is a comment because there's 2 slashes before this. So this doesn't actually get run by the computer. When the computer sees 2 slashes in front of a line, it knows, okay, this is a comment, so I won't run any of it. So all of this stuff will not get run. So let's see exactly what's going on. Let's look first at the variable which we've called average rating. So this right here is the structure of a variable. So I'm going to copy paste this into my code. So if we want to add another line to our code, then we can just put it below like this. So let's see what exactly is going on here. Well, we see that there's a few different parameters to when we're declaring a variable. First of all, there's the descriptor, which is double. Then there's the name of the variable, which is average rating. Then there's the value of the variable. So this descriptor here, double, is something that we call a data type. It's a type of value. And here, this word double is telling us what exactly average rating is. In our case, we know that the average rating of a movie can be any decimal value. It can be 4.5 stars. It can be 3.14 stars, and so on. And in order to specify that it has to be a decimal value, we use this descriptor double in front of the variable. So the first term when we're declaring a variable will always be the descriptor. After that is going to be the variable name, and this can be whatever you want it to be. In this case, we've chosen to call it average rating, but we could have just as well chosen to call it like this, where we actually spelled it correctly. But sometimes we want it to be shorter, so this is just the name we chose. After that, we have an equal sign, and then the value of the variable. So now we've changed the value of this specific variable to be 3.14. So now if we use what we learned previously, which is how to print, and we print out average rating like this, and notice that in this case, we don't have quotes around the word average rating because we actually want to print out the exact value of average rating. Like, for example, if we did include quotes around this, then this is what would be printed out. We'd see that we would, oh, shoot. I will also do this real quick. So we see that here. Oh, and what I added here, end line, just means that we start a new line whenever we're printing out the next thing. So we see that here we print out I am the best and then average rating. But instead of printing out the actual value, we've printed out the literal words average rating because the quotes around the words just means that we want to print out the actual word. But if we want to print out the actual variable, then we remove the quotes and we see that now we're printing out the value of this variable. So let's see how exactly this is going to work with something else. For example, as we mentioned previously, we know that your age has to be a number. So let's look at how this works. Once again, we see that this data type follows the exact same structure. First, we have the descriptor of the data type, which is int. Now, what is int? Int is short for integer, which essentially just means any number. So this can be 0, 5, 6, but it cannot be a decimal like 5.5. It can't be a word like cool, and it can't be a character like a. Int means that whatever variable you're describing next has to be a number. So we use the int data type to describe our current variable. So our current variable, we decide to call it age because it's describing our age. And finally, we set it equal to whatever it's called. So in this case, we could say that our age is 13. And once again, if we choose to print out the value of this variable, we see that it prints out 13. And for one final example, we're going to be looking at something that we call strings. Now, following the structure that we've had throughout the entirety of today's lesson, we know that the first term is going to represent the descriptor of the data type. The next term is going to represent the variable name. And the last term will represent what the variable equals. So what is a string? A string is essentially just it's basically just any sort of spelling thing, any combination of words that you might be able to think of. It could be a sentence, it could be a couple characters, it could be anything that use the English alphabet to write. So you can just, whenever you see the word string in front of a variable, you can think, okay, I know that this variable is going to be equal to a lot of words. Then we come to the variable name, which in this case, we just decided to call name because this variable is going to describe what our name is. And lastly, we see what it's equal to, which in this case is John Smith. So if we print out the value of this variable, we're going to get John Smith. Yeah. So, but what happened? So now we've seen what exactly happens when we try to print out things like these variables, sort of. And we've seen how we can describe and declare a variable by using this specific order of first declaring the data type, then using the variable name, and then setting it equal to some value. But what happens if we try to set a variable equal to something that its data type does not match? So for example, if we look here, what if here we try to say int name equals John Smith? Now, this doesn't actually make sense because we start out with the descriptor int, which implies that this variable is going to be a number. So for example, here we see int age equals 13 because 13 is a number. But instead, here we say int of this variable, which we call name, which we'll call like name1, is equal to not a number, but a list of words. So what happens when we try to run this program? And we see that we get an error. And the reason for this is because the descriptor that we've thrown in front of the variable does not match the data type that does not match the data type of the thing that we've sort of tried to make our variable equal to. We've tried to make our variable equal to a string, but a string is not an int. So as a result, the computer program gets confused and it won't run the program because it doesn't know what to do. If we instead change this to an actual number, like an integer, then things will be completely fine, as you can see. Yeah. Similarly, if we try to declare say that this variable down here is a string. This variable being a string, if we remember from before, a string is like a combination of words. But if we try to make a string a number, then this variable also will throw an error. We see that the program does not run. And the reason for this is because this variable is declared to be a list of words. It's not declared to be just a number. So things won't work out in this case either. Yeah. And again, you guys can also sort of follow along and try to run these in your own compiler as we go along, because I think it's always easier to learn if you're trying to do things yourself and typing them into your own compiler, as opposed to always just watching somebody else do the coding. But yeah, this is sort of how exactly variables work. So if anybody has any questions, at this point, then you can feel free to ask. And we'll wait like a minute or so just to see if anybody has any questions. Yeah. So this double here sort of just indicates that this variable is going to be a decimal. So for example, like 4.5, 0.3, that sort of stuff. Does anybody else have any other questions? All right, if not, then let's continue. So now moving on, let's get into input and output. So computer programs would not be as powerful as they are today if we weren't able to tell them information. And a lot of the times, we want a computer to sort of be able to understand what exactly we're talking about. So the way that computers are going to be able to understand information, at least in C++, are through these commands, which we call cin and cout. Now, we've already sort of discussed what exactly cout does. For example, here, we've talked about how when we put cout and then two less than signs and then a message, then cout will actually end up printing out that message. We've also shown how when we use cout and then the name of a variable, then the computer will print out what that variable equals. So that sort of tells us what cout does. It's a way for the computer to output information to us, to tell us what it knows. But what about the counterpart of this, which we call cin, or input? What happens when we want to tell the computer some amount of data? How can we do that instead? Well, the way we do this is as follows. So let's sort of copy the code that we have here and go through what exactly is happening here. So the first thing that's going on in this line of code is that we're declaring an integer x. Except you might notice in this case, well, wait, something's a little off because we're not setting it equal to anything. Like normally, as we looked at before, there's a structure to variables. The first thing we do is we have the data type, which in this case is an integer or a number. Then we have the variable name, which in this case is x, and then you have the value that is equal to. But in this declaration, we don't set what it's equal to. Why can we do that? Well, the reason that it works in this case is because of the second line. In the first line, we're just saying that, okay, we're saying x to be an integer, but we can actually split up the line where we say what data type x is and what we set x equal to into two different lines, which is what we're doing here. So in the first line, we're just saying, okay, x is going to be a number. And in the second line, we see the funky thing that we've written here, which is cin, and then two greater than signs, and then x. And what this does is it reads x from user input. So let's see what exactly happens here. Okay, so if we run this program, we see that, okay, nothing is currently being printed out. But you can notice that down here, I can type numbers into this box. So let's say that I type in the number 205 and hit enter. You're going to notice that this program prints out the number is 205. Okay, hold on. So what exactly happened here? Well, as we first declared that x is going to be an integer. And after that, we ran this line. And this line sort of just tells the computer to, whenever you see the word cin, what's happening is the computer is going to wait for you to type something in and then assign this variable equal to the value that you typed in. So you might have noticed that we started out with a blank box. And when I typed in the number 205 and hit enter, the computer immediately went, okay, the user just inputted the number 205 into the program. I see that I'm supposed to do cin x. So I'm going to set x equal to 205. So that's what happened. As soon as I hit enter, x took on the value 205 because this is saying that x is going to take on the user input. And then after that, it ran this line. So what this line does is it's a cout line, And we know that what cout does is it prints out the current value of what's going on. So it first prints out so we see that this message is in quotes. So it's going to print out this message. It's going to first say the number is, and then after that, we see that it prints out something else. It prints out X. Since there's no quotes around X, it doesn't print out the word X as a message. It prints out what X equals to as a variable. And since in this line, we just assigned the value of 205 to X, it's now going to print out 205. And that's how we ended up getting this line. So to briefly recap, first, we say that X has to be a number. Then on this line, we read in the value 205 from user input and set X equal to that value. So after this line, X is equal to 205. And finally, our computer will output the number is 205. Yeah. So let's quickly go over another example of how this can work, which is with strings. Oh, can I play the code again? Of course. So you see this code, and then if we type like 963 or something, or we can type any number really, and then hit enter, we see that the program will say the number is 900, very long number. Yeah. What is the difference between using greater than and less than signs? That's a good question. So whenever we use greater than, I'm not actually entirely sure of the significance, but it's sort of just customary that whenever you see in, you have to use these greater than signs. And whenever you see out, you have to use these less than signs. And I know that it can get really confusing because I remember whenever I first started out with C++, I was mixing up the less than and greater than signs all the time. And it was really bothering me because I didn't know which ones to use. So I had to keep switching them. But as we use C++ more and more, it becomes sort of second nature. So yeah, it's just sort of something that's attached with using C in and C out. Like whenever you're using input, use greater than signs. Whenever you're doing output, use less than signs. Yeah. So now let's look at another example. So we see that this example is actually very similar to the one that we had previously. We see that first, we're declaring a variable again. We see that S is going to be a string. So we know that S is going to be a message. Then after that, we read in S from user input. Then we print out the value of S. So what happens here? If we click run, then we can type in any message like, I am the coolest! Exclamation mark. Oh, wait, actually, sorry. Okay. Let's try this again. Okay, so I can print out any message. So for example, let's say that I want the message to be password. And you'll see that this will print out the string is password. So once again, this is very similar to what happened in the previous example. What's happening is we define that S has to be a variable. The next line, C and S, will wait until I, the user, put something in. So in this case, I put in the word password. So saying C in S will set the variable S equal to password. So after this line, S now stands for password. And then after that, we use cout blank. So cout, the string is S. So we print out the message the string is, and then we print out the value of S, which in this case is password. So this is another way that we're using cout and cin. So you can see that it's not just limited to a single integer data type, but we can use any sort of data types. We can use words, we can use characters, we can use numbers, whatever we want, as long as we're making sure that we're defining the variable like appropriately. Why does it only play one word? The reason it only plays one word sort of just has to do with how C++ is defined. Whenever you have C in S, C++ will only take like sort of the first word that you write out and not take the rest of the line. There are ways that you can make it to take the rest of the line, but these are pretty complicated, and I don't believe that you need this for the simplest few USACO bronze problems. So we're not going to go over that for now. Does anybody have any other questions? let's move on to the next question. So now that we've sort of talked about two things, which are variables and input and output, let's move on to a brief aside, or let's just quickly talk about something else before we move on to the next topic, which is operations. So something that you can do inside of C++ is you can do the operations, like, for example, addition, subtraction, division, multiplication, and all that sorts of stuff. And there's a few different ways that you can do this. So let's go over the main types of what's going on. Okay, so I put this in the compiler. This probably looks a little confusing. Let's go over what's exactly happening. So, okay, I think I want to do this like this. So the first thing that we're going to do is the main way. So the ways that you're going to be using operations inside of Java is sort of similar to how you might expect. If you want to add two numbers, you use the plus operator. So this is adding two numbers. If you want to subtract, use the minus operator. If you multiply, use the star. And if you want to divide, you use the slash. And something to note is that you can use parentheses to order your operations. And so the standard order of operations does follow inside of Java. So yeah. Okay. Now, something important to note is that there is something interesting about how C++ does its division. If you look here, we see that we've printed out two different things. One is 2 divided by 3, and one is 2.0 divided by 3. And I mean, as we all know, 2 is the same thing as 2.0. So you might expect that these two will print out the exact same value. Except when you run it, they don't. One prints out 0, and one prints out a decimal. Now, we clearly know that when you divide 2 by 3, you do not get 0. So what's happening here? Well, the reason for this is because whenever you divide two integers, remember that something C++ does is it remembers the data type of what's happening. In this case, both of the numbers you're dividing are integers, so the program will spit out another integer. But in this case, we're dividing a double, or like a decimal, by another integer. So dividing a decimal by an integer, the program sees, hey, one of these is a double. So as a result, the value that it outputs will also be a double. So it'll also be the exact decimal value. But here, the program will sort of not include the remainder of what your division is, because both of the data types of the numbers you're dividing are integers. So that's something to sort of keep track of. So for example, if I change this to like 4, and then this to 4, and then ran it, we see that it now inputs 1 and 1.333. So 4.0 divided by 3 does in fact give us the decimal value 1.33333. And the reason that the second output statement prints this out is because 4.0 is a decimal, so this will print out a decimal, whereas the first one only has 2 integers. And the reason that the first one prints out a 1 is because the integer data type does not care about remainders. So when we do 4 divided by 3, it just cuts off all this decimal remainder stuff and only prints out your integer. So that's something to sort of note about decimals. How do you print out a fraction? In C++, there isn't a very convenient way to print out a fraction, although most of the time you won't need to print out a fraction, as most operations will generally be fine if you use doubles. So printing out fractions generally is not necessary. Yeah. Okay, now let's sort of go over a few other things. Okay, let's go over a few other ways that we can change numbers. So once again, let's first read in an integer from our input. Then we're going to do a few things to it. So let's say that we read in the number 9. Okay, what is happening here? So again, the first thing we do is we declare that the number that we're going to be reading in is an integer or a number. Then we read it in. So after we type in 9 and hit enter, x has been assigned the value of 9. So there's a few different commands you can use to increase and decrease the value of this number. The first one is x plus plus. This is shorthand notation for increasing x by 1. So when we do x plus plus, you can think of, okay, our previous value of x is 9. After we type x plus plus, it just becomes 10. So after this, x is equal to 10. So coming into this, we now do x minus minus, which does the exact same opposite of x plus plus. It decreases the value of our variable by 1. So after this, x equals 9, because we decrease the value of x by 1. Next, we increase x by 2. So this plus equals here. So we see that here, this plus plus, it's not very versatile because we can only increase x by 1 when we use plus plus. If we want to increase x by greater amounts, then we're going to use this plus equals method here. When we say plus equals and then some number after it, then this tells us how much our variable is going to increase. In this case, we say x plus equals 2. So we change x and add 2 to it. So x is currently equal to 9. So after this command, after this, x will equal 11. Similarly, x minus equal 2, this just says, okay, now we subtract 2 from x. So 11 minus 2 is 9. So after this, x equals 9. Now we multiply x by 2 because this times equals. So after this, x equals 18 because 9 times 2 is 18. Now we divide x by 2 because divide equals indicates that we divide equals by the number that's written here. So after this, x equals 9 because 18 divided by 2 is 9. And finally, we print out this sort of confusing mess. Okay, and we'll briefly go over what exactly is happening here as well. So one thing to notice is that there is a certain way that Java indicates what is true and what is false. It indicates what is false with the 0, what is false with the 0, and what is true with the 1. So let's see what exactly is happening here. Oh, so somebody's asking, can I play the code again? Okay. So if I run and then I type in 9, then it outputs this 1. And it does all of these small micro steps in between. And then finally, after you do all of these micro steps or like these smaller steps, it finally prints out this value based on what x is. But notice that at this point, x is equal to 9, and we're going to quickly go over what's happening here. So here we say that x is equal to 9. So, okay, let's see what's happening. So we say that when x is false, it's 0, and when it's true, it's 1. Okay, so the first thing to note, is x equal to 1? The answer is no, x is not equal to 1 because x is 9. So this is going to be represented with a 0. Now we have these two weird sort of standing up thingies. Oh shoot, what happened here? So we'll indicate it like this. Okay, now let's look at what exactly is going on here. Okay, so this percentage sign is a special operator that indicates that we're taking the remainder when dividing by. So x is a 9, and when we divide 9 by 2, we get a remainder of 1. So this statement is in fact true because x remainder 2 is equal to 1. So we're going to say that this is equal to 1. And then we have this and thing. And then we have something else. So x remainder 3 is equal to 0. Is this true? Well, when we divide 9 by 3, we know that 9 is evenly divisible by 3. So it is in fact equal to 0. So this is also true. So we'll mark this with a 1. Okay, so now finally, our expression will evaluate into what this is. But what is this equal to? Well, I don't think I have the time to go in depth into what this is saying, but pretty much these two ampersands, or sorry, not ampersands, but these two symbols represent an and these two symbols represent an or. So these are sort of operators that do something very special. So this and will take two numbers and then return either a 0 or a 1. So it will return a 1 if both of the numbers are 1 and a 0 otherwise. So in this case, we see that we're saying 1 and 1. So because both of them are 1, it will return a 1. So now we're left with something that looks like this. So this expression in here evaluates to 1 because 1 and 1 is equal to 1. But for example, if we had 0 and 1, that would be 0. If we had 1 and 0, that would be 0. And if we had 0 and 0, that would also be 0. So now I have this expression, and OR is sort of the opposite. Or not the opposite, OR is something different. OR pretty much says if either one of the operators that I'm being applied to is a 1, then I'll print out a 1. So in this case, we're doing 0 or 1. And since at least one of these two, since at least one of the parameters being passed to it, so this one is a 1 right here, we see, is a 1, then it's going to print out a 1. So this thing will always print out a 1 unless both of the things next to it are zeros. But since this one's a 1, it'll print out a 1. So as a result, we see that this does evaluate to a 1. So in the end, after all these sort of complex expressions that are being manipulated, it prints out a 1, as we can see here. So this sort of goes to show that in between the place where we read something in and output that thing, a lot of different sort of operations can be applied to that specific variable before we print it out. Like we see here, we increased x, we decreased x, we multiplied x, we divided x. We did a lot of things to it. And in the end, we got that x is equal to 9. Then before we printed it out, we did even more things to it. And we ended up getting that we're printing out an expression value of 1. So that's sort of what happens here. Yeah, this is a brief overview of all the different things and all the different ways that you can manipulate variables inside of C++. Okay, and unfortunately, we are running a little low on time. So I will quickly continue on to the next part. Okay, and let's also quickly talk about libraries. So you might have noticed from above that we're doing hashtag include IOStream. So a lot of functions, although they are built into C++, are sort of included into files, but not all of these files are loaded automatically into your C++ program. So when we write hashtag include IOStream, it's basically saying, okay, computer program, download the package IOStream. And every single package allows you to do something different. In this case, what IOStream allows you to do is it allows you to input and output different things. So if we actually removed this include line right here, then we would no longer download the library that allows us to input and output things. So if we try to run this, we'd get errors because the files inside of that library are not downloaded to our program at the very beginning. So our computer program doesn't actually recognize these commands anymore. So there are certain commands that require us to first download the libraries that have those commands before we can use them. And IOStream is one of them. So here are a few common IOStreams that work. So for example, algorithm. So if we wanted to use the algorithm library, we would do hashtag include algorithm. The CMath, which allows us to get math functions. Vectors, which give us the important array data structure. So we can include CMath and also include array. Yeah, so sort of doing these hashtag includes downloads the library at the beginning of the program so that we can use the functions in these libraries. And of course, there's IOStream. Oh, and then of course, the big one is bits.stdc.h. And this is just a very, very convenient sort of library that allows us to immediately, sorry. Okay, so this is sort of a very convenient library that just allows us to include all libraries. So for example, we could just type out all of these includes manually, but because a lot of the times programmers are lazy, they created this way to just automatically include all libraries into your program without having to manually type them all out. And that's what this one line include bits/stdc++.h. If you type this line, all of the libraries will automatically be included. So yeah, that's a brief intro onto how libraries work. So let's move on to the next part. All right, now let's move on to data structures. So the main way that we're going to be using data structures is, well, what happens if we want to include a list of numbers? We've talked about integers where we set a variable equal to one number. But what if we want to set a variable to be able to hold a lot of numbers? The way we're going to do this is with something called a vector. So, okay, actually there's two ways. There's an array and there's a vector. So I'm going to briefly go over both of them. So what we've done here is we've declared an array. So okay, let's just make this a little simpler, like this. Okay, so what's going on here? Well, here we first declared the data type that, so this is sort of like a list of numbers. A lot of times we don't want to just hold one number. We want to be able to hold a lot of numbers, and that's what we're doing here. So what is going on in this declaration? Well, first we declare the types of values that we want our list to be able to hold. In this case, we want to hold integers, so we're saying int at the very beginning. After that, this right here is the name. So this is ARR, so the name of our list is going to be ARR. And after that, we include how many elements or how many numbers we want in our list in parentheses. So in this case, we want 3. And finally, we can say that it's equal to like this stuff. So this is our list of numbers in curly brackets, 0, 1, 5. Now, how do we reference specific numbers in this list? Well, the way we do that is by first typing the name of the list, or sorry, the name of the array. Oh yeah, and this is a list of numbers called an array. So the way that we reference specific numbers in our array is by first typing the name of the array, which in this case is ARR, and then typing the specific index of the number that we want. So for example, the second one. Let's see what happens. Okay, wait a second. You might notice that here we're printing out the second number, but we're getting 5. 5 doesn't seem to be the second number. What's happening here? The reason for this is because in C++, arrays are numbered starting from 0. So this is the 0th element, this is the first element, and this is the second element. So 0 is the 0th element, 1 is the first element, and 5 is the second element. So when we type C out array 2, we're printing out technically the third element. If we try to type like 3, for example, then we would get an error. We basically get an error. In other words, we get nonsense. Like we see that this is clearly not one of the numbers in the list. And the reason for that is because this array is only meant to hold 3 numbers. And when we try to address array 3, that's trying to reference the fourth number in our array, which does not exist. So it doesn't make sense. And something else to note is that you can edit the elements in your list by doing things like this. So if we wanted to change the second element, we could set it equal to like 500. And now when we print out ARR1, we see that instead of printing out 1, we're actually printing out 500 because we've changed the second element to be 500 before we print it out. So this is a brief look into how arrays work. Now, the more common sort of way to store numbers is through something called a vector. And the reason that vectors are more common is because we see that here for arrays, we have to declare the number of elements in this list. So we see that in this declaration, we have a 3 here. And this tells us that the number has 3 elements. But the problem is that you cannot change. The problem is that you cannot change the number of elements in the array in this case. So that's sometimes sort of annoying where we don't know exactly how many elements we want in the list. So as a result, the solution to this is to use something that's called a vector. Like this. And if we want n elements in the array, we can say it like this, I guess. Yeah, so something like this. We can also say like cn. So what this is doing here is, once again, we're reading in a number n from input, and then telling us that this list or this vector is going to have size n. So this is an array. This is an array or slash list of size n. So if you don't, so here, the word vector int in front. So the vector just tells us that this is an array, and the int tells us, okay, inside of this list is going to be integers. This is the name of the array, and this is the number of elements. And this is slightly different than the previous declaration, because in this case, we see that this array is going to have n elements. But this is not something you can do with the previous declaration. In the previous declaration, when you're declaring the number of elements in the list, you have to specify exactly how many elements are going to be in that list. So you have to specify like, okay, it has to be 5. You cannot specify a variable, for example, n number of elements. And the way that you can sort of, and for this one, you can also sort of add elements and remove elements. So the main way that you're going to be adding and removing elements are like this. So we have to add an element, you're going to do push back. So for example, if we want to add 8, then we would push 8 into the array with ARR.pushback8. If we then wanted to add another element, we'd keep on doing this. So for example, like this would change our list into 826. Okay, and let's see what exactly this does. Oops, forgot my semicolons. Oh, what? Okay, actually, I guess I'll just quickly not go. Okay, pretty much after you sort of have this, what's going to happen is our function ARR is going to equal the list of elements 8 to 6 because we've pushed all of them into the array. So after that, we have two more functions that we're going to cover, which are pop back and size. So pop back removes the last element of the array. So if we run pop back, then 6 is currently the last element of the array. So our array will now equal 8, 2. Because we removed the 6. And then finally, ARR.size gets the size of this array. So we see that we've added 3 elements to the array and then removed 1. So if we check what this is equal to, then this is going to be equal to 2 because there are currently 2 elements in our array. And yeah, that's a brief overview onto vectors / arrays. And did somebody raise their hand? I think that somebody might have had a question, but either way, if anybody has any questions at this point, then you can feel free to ask. Oh, yeah, and don't worry about having screenshots. Don't worry about having to take screenshots of the slides. We're going to upload everything, including recordings of all of the lessons and all of the materials. So for example, slides, homework, that sort of stuff. Okay, well, if the class has homework, I don't think this one does, but we're going to upload all the materials onto our website later. So you should still be able to access it. Yeah, let me see if I can find the link. Okay, I don't believe that it is currently up. Okay, I don't believe that it is currently up because today's sessions have not ended yet, but you should be able to find it here whenever the website goes up. I don't believe that this page currently exists though, but it should be up and running soon. Yeah. Okay, so I have 5 minutes, so I guess I would try my best to go over sort of the rest of what's going on. So let's look at the next slide. So this is some other stuff that sort of can be done with vectors. So note that whenever you declare an integer array, things are initialized to random values. So for example, if we declare an array like this, then this integer array is going to contain 10 random values. However, if we declare a vector, then the values of all the vectors will default to 0. So as soon as we declare this list of integers, this will contain 10 zeros, but this one will contain 10 random integers. If you want to fill your list with different sorts of things, then you can use this command. So you can see here we're declaring a list or a vector of strings, and we're setting all of them to be ABC. So this 10 describes that there's going to be 10 of them, and this describes what we're setting every position equal to. So this vector / list is going to have 10 copies of ABC. And finally, for example, like this, as we mentioned before, what the method pushback does is it adds an element to an array. So this is going to add something to the end of an array. Okay. And lastly, let's talk about loops. Okay, actually, if you also need the slides, I'll also actually quickly. Okay, I'll also post the link to the slides in the chat. So this should also be the link to the slides if you need them. Yeah. Okay, so lastly, let's very quickly talk about loops. So let's say, for example, that you want to do something 100, like a million, maybe even a billion times. You don't want to be pasting the exact same block of code over and over. And the way that you're able to simplify this in C++ is through a control structure, which we call a loop. So there's two main types of loops, for loops and while loops. And each of them allows you to do something over and over again, so you don't have to type it again and again. So for example, if you want to print out hello world a billion times, you can do it in 3 lines of code instead of a billion lines of code of copy pasting C out hello world over and over again. So this is the main structure of a for loop. Let's see what exactly is going on here. So a lot of the times, whenever we declare a list, we want to print out everything that's in the list. So for example, let's see what's happening in this code. So the first thing that we're going to do is, let's declare int ARR10. So if we remember from the previous slide, whenever we declare int ARR10, so like an integer array of something, what's going to happen is it's going to contain random values. So how can we like print out every single value? Well, the way we can do that is with something called a for loop. So let's look at what's happening in this for loop here. There's 3 different parts to a for loop: the variable declaration, the out of bounds, which is the first part, the out of bounds condition, and the increment. So what happens in a for loop is it starts out with the variable declaration. So this is something we're familiar with. You just declare a variable to something else. So in this case, we're setting the variable I to be equal to 0. So what happens after you set I equal to 0? Well, once that happens, you now run the code one time. So I is equal to 0, so we're going to print out the first element of the array. After running this, what's going to happen is we now run the incrementer. So the incrementer happens after every iteration of the loop. In this case, the increment is I++, which increases the value of I by 1. So now I goes from 0 to 1. And after this, we check the boundary condition, I less than 10. 1 is still less than 10. So we run the code again. So now I is equal to 1. So we do cin ARR1. So now we're going to be reading in the next value of our array. Now after this, I++. So I goes from 1 to 2. We check, is 2 less than 10? No, it still isn't. So we run the code again. And this keeps on happening until finally the boundary condition is met. Then we finally leave the code and then everything is good and dandy. So for example, if we change this to 3, let's see what happens. Okay, also, sorry, I just realized I made a mistake. Ignore what I said previously about the random thing, because that actually, or this list taking on random values, because that actually isn't relevant in this scenario. But like if I type in 3 integers like 5, 2, 6, then we see that it's now printing out 5, 2, 6. So what happened is inside of this for loop, what we were able to do is this for loop allowed us to read in all the different values inside of this array. And then after that, we were able to print out 5, 2, and 6. And this printout is sort of done with this for loop as well. And I think that this is probably a little confusing because I unfortunately do not have that much time to go over everything. But if I'm able to, I'll try to go over this at the beginning of tomorrow's lesson as well. So yeah, this is sort of a for loop. And next, this is a range-based for loop. Okay, I'm a little over time, but that's okay because there's no class after. But okay, this range-based for loop is sort of similar to what's going on in the previous one, except it's a little more clean. So here we're declaring a list of 10 elements. And what this for loop does is we see that we have this. So what's happening here is this is saying for every integer x inside of array, we read it in. So here we've declared that the number of integers inside of our array is 10. So this is saying for every integer in your array, so for all 10 integers, we're reading it in. So for example, we can type 10 integers, 1 through 10. And it'll read all of them in. And what this final loop does is it's saying for every integer inside of your array, so again, there's 10 integers, we're printing all of them out. So here we've printed out all 10 integers inside of our array. Okay. And this is a while loop. I do not have enough time to like overall describe what's going on, but as a brief intro as to what's happening here, what happens in a while loop is a while loop will keep on running what's inside of it as long as a condition is met. So this while loop will keep on running x divided by equal to count plus plus, x divided by equal to 2 count plus plus, and then keep on going forever and ever until x is no longer greater than 0. Then it'll stop and then it'll print out count. So for example here, let's see what happens. So if we run this, it prints out 7 because count starts off at 0. X is equal to 64. So first, x divides by 2, it becomes 32. Count increases to 1. So now count is 1. So count is 1, x is equal to 32. But x is still greater than 0. So now x divides by 2, count plus plus. So count becomes 2, x is equal to 16. But count is still greater than 0. So we run it again, count becomes 3, we divide x by 2, it becomes 8, and then so on until finally x becomes 0. And at this point, we run the loop 7 times, so count will be 7, which is why we print out 7. So a while loop is, as long as this condition is true, we keep on running what's inside of this. And you might notice that this sort of reflects what happens in a for loop, or like this sort of for loop, because this for loop is sort of like a while loop, except it has a few extra steps. So pretty much this for loop will keep on running until this condition is met. So this for loop is like a while loop, except with this condition. So the middle thing between the two semicolons in a for loop is saying like, okay, this loop will keep on running forever and ever. So we'll keep on executing whatever code is in this for loop until this condition is met. It's just that it has a few extra steps, which is that right before you run anything in the loop, you're going to execute this thing, which sets your variable equal to something. So here you say I is equal to 0. And then you have this I plus plus thing, which is just saying, okay, at the end of every iteration, you do this. So it's sort of like an extended version of a while loop. Okay, and the last thing we're going to briefly cover is conditionals. I know I'm 3 minutes over time, but let's spend like one last minute on this. Come on, guys. Okay, conditionals are fairly simple. They're just saying like, okay, what is happening? Okay, so for conditionals, a lot of the different times, there's like a lot of different things that you can do, right? And in a computer program, lots of times there's like cases that you want to consider. Like if this happens, then do this. But if this doesn't happen, then we do this instead. And whenever we want to address this inside of a computer program, we use something called a conditional. And there's 3 different types of specific things that we want to use. The first is an if statement. The second is an else if statement. And the last thing is an else statement. So what exactly happens here? So let's say that we have an integer and we read it in, as we've done many times. In this if statement, what this if statement is basically saying is, okay, is x greater than or equal to 20? Because we have this if before the condition. We check the condition, and then if the condition is true, we print out x is greater than 20 because that's true. Okay, but then if it's not true, then we move on to the next statement, which is else if x is greater than 10. Okay, so if x is greater than 10, then what else can we say about x? Well, in this case, then we know that x is greater than 10. So this else if statement is just sort of like, okay, if the thing before wasn't true, then what is this other condition true? So if x is not greater than 20, then we're going to now check this condition. Okay, but what if this condition is also not true? Well, then in this case, we move on to the next else if statement, which is x is greater than or equal to 0. So we can print out here, x is greater than or equal to 0. And then finally, if none of these are true, then else just says, okay, well, none of these are true. So this just means x is not greater than or equal to 0. So this is sort of like a chain of things where it's like, okay, you keep on doing this, keep on checking each of these conditions. And then once you find a condition that's true, then you execute the code that's right below it. So for example, if we run now and we put in an integer like 10, we see that we're going to get x is greater than or equal to 0. If we execute like 7, we get that x is greater than or equal to 0. But now if we execute like 23, we see that x is greater than or equal to 20. So what specifically is happening here is we put in x is equal to 23, it first checks the condition x greater than 20. This is in fact true. So we print out x is greater than 20 and we skip everything else. If we instead put in like 15, we see x is greater than 10. So what happens here? We first check if x is greater than 20. This is not true. So we move on to the next line. Is x greater than 10? Yes, this is true. So we print out x is greater than 10. Great. And finally, if we put in a number like -8, we check. Is x greater than 20? No, move on. Is x greater than 10? No, move on. Is x greater than or equal to 0? No, move on. And finally, else. This else just says, okay, nothing else above us was true. So we just default to the statement, which is x is not greater than or equal to 0. This is our last resort, and that's the end. Yeah. So hopefully you guys all were able to sort of learn something from this lesson. Next week, tomorrow I'll probably quickly go over how exactly for loops and while loops work a little bit more in depth. Although I'm not sure if I'll have time. We'll sort of see tomorrow, yeah. And tomorrow we're also probably going to be covering a couple of simple USACO bronze problems. So today was sort of an overview on how exactly coding works. Tomorrow we're going to see how we can use computers and computer programming in C++ specifically to actually solve problems. Yeah, so thank you so much to everybody for coming, but don't leave yet, because our most important event, which is watching how women thrive in STEM, along with lots of very entertaining guest speakers, is going to be happening at 7 o'clock today in about 50 minutes. So stay in this Zoom room if you're interested. And for everybody else, if you have any questions, then I'll stay back for a little bit longer to answer those. So you can feel free to ask me if you have any questions. But other than that, hopefully you guys learned something. I'll see you guys tomorrow and have a good day. Bye, guys.